These are one set relation. What about two set relation? Now we have A Cartesian product B. That means what? We now have a x, y. I make a mistake, so it's B. So x, y, x come from A and y come from B. And if x, r, y, that means x, y from two sets fulfill the relationship R. Here is an example. Y equal x squared. So x come from a set A, which is real number. Y come from a set B, which is also real number. And the relationship is what? Is something power square. You may wonder, oh, how do I write square root? Half power. So square root is half power. Okay? Then, so what is a function? You are actually having a relation. What? A relation is what? You have two sets. A set A and a set B, and you have x and y. X comes from the first set, y comes from the second set. That all the possible x, y that this is true is a function. And this is the high school math you learn, but now you understand it from a point of relation. This A, B, we give them name. A is called domain. You can think of it as input. What is a function? It's just input and then output. All the possible input, we call it domain. All the possible output for this part, there are three names: codomain, image, and range. I will say that in set theory, just say this is codomain and this is codomain, that's it. But then in linear algebra, they don't call it codomain, they will call it range or image. And what is inverse? Inverse is basically this. You know y equal x squared, right? So you probably want to know, how do I write back x as something y? So we know it's square y. This is inverse because this means we have a relation R, and this means we find the opposite. So this is called inverse. So that means what? A relation is any xy such that x, ry is true. So that means it's a set of xy inside the R. What's inverse? You flip the position. So we want to find y in terms of x such that xy is in R. So which is exactly the set theory representation of this process. Let's look at simple example. So I have a set A and I have a set B. Both are 1, 2, 3, 1, 2, 3. And my R is 1, 2, 1, 3, 2, 3. Notice that this is not the what? Cartesian product of AB. Cartesian product of AB will be 1, 1, 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2, 3, 3. Relationship is always a subset of the biggest possible combination you can get. That's why we talk about power set. That's why we talk about Cartesian product. And this is a particular subset. Then what? What's the domain? Input space. But if we look at R, only 1 and 2 appear. 3 is not used. That means what? That means I have 1, 2, 3 here. This guy is not allowed to get inside due to some reason. Okay? So this is a smaller set than my A. So this is called domain. I'm not saying this whole thing is a domain. Okay? That means you have a machine F. These are all possible things you can put inside. These are all possible things you can get out from the machine. But actually some of them can go in and only some of them will go out. That means, for example, this guy will never produce by the F. Or this one you cannot get in. What are examples? Suppose F is division, then 0 cannot go inside because you cannot divide by 0. So domain means what are the input you can have in the R. And range means what are the output. The output is 2, 3, 3, that means 2, 3. And what is the inverse? Inverse means for all the x, y you see, you flip them. Then you just flip them. Really, just flip them. And then, here's a funny part. Suppose I give you 1, 2, 3, B is 1, 2, 3, and I give you this R. Can you tell me what's this R? This is called reverse mathematics. This R actually is smaller than, and the inverse is larger than.